Hello everyone, welcome back to the channel. In this video, we are going to discuss about the system design behind Instagram. This may not actually be the system design or the architectural design that Instagram uses, but this is one solution that we could actually discuss when we face this question in an interview, right? So let's first talk about what Instagram is. So we probably all know that Instagram is a social networking platform. Instagram lets its users upload photos and videos, and also lets its users follow other users so that one can see others' photos and videos in his or her feed, right? So that's the basic functionality that Instagram provides. There are more things like reels and stories and stuff, but we are not going to cover that as part of the this interview problem. Yeah. So, if we have to talk about the functional requirements for this system, so those would be the very first would be to let users upload videos and download videos. Download as in see photos and videos that other users post, right? The second would be there should be a feature to search users or search photos based on caption or tags or whatever. The third would be to follow users, and the last would be generating a news feed for every user based on the people or the pages or tags that one follows. So here I have noted down the functional requirements that we just spoke about. Apart from these, we also need to take care of a few non-functional requirements. So the very first would be the debate between availability and consistency. And for a system like this, we do know that consistency plays a lesser important role than availability does. So what I basically mean here is it is totally fine if a few users see my photo a few seconds late rather than not seeing them at all, right? So if I give you an example, let's consider Jennifer Aniston showing up on Instagram. And when she did, there was such a huge rush of traffic to her profile to follow her or maybe to like the photo that the system choked down and Instagram had to go down, right? So a better situation would be that some of the users or some fraction of users see her photo a few seconds late, but at least Instagram would be available, right? That is a whole better scenario. So we can always there is always a trade-off between availability and consistency, and in a system like this, we should be prioritizing availability over consistency. The second thing would be our APIs or our services should be less latent. We do not want people scrolling on the feed and waiting for the photos to show up. We want a very less latent system, probably around 200 or 300 milliseconds. And the third thing would be that our system should be reliable. And what I mean by reliable is that once somebody uploads a photo or a video, it should be guaranteed that the photo or the video is available on the system until or unless the user decides to delete that, right? We should not lose data. So reliability is at uh, its peak importance. Let me note the non-functional requirements down. So here I have noted down the non-functional requirements as we had discussed them. Before we dive into designing the system, we also need to take care of a few points. Uh, those being the system would be very read heavy, right? So a user might post one or two photos per day, but he or she would view 100 photos. So reads are always greater than writes on our system. So our system can be called as read heavy. There would be no limit on the number of photos or videos a user can upload. So storage is something that we need to take care of. We discussed that latency should be less, and we also discussed that reliability should be at its peak. So yeah, these 2 points are something that we also need to uh, take care of. Now, if now since we discussed that there should be no limit on the number of photos or videos somebody uploads, we need to decide on the capacity. So capacity planning for probably some few years, right? So let's go ahead and try and do that. Let's consider we are targeting some user base of maybe 500 million to a billion users on our platform, and let's consider we have around a million daily active users. Daily active users, right? We can also consider probably an average of 2 photos per day, right? Because a lot of them do not actually post photos and few of them post a lot of photos. Let's keep an average of 2 photos per day for each users, for each daily active users. So if we consider 1 million active users every day and we consider 2 photos per day as the average rate of uploads, we can say that per day our system would be receiving 2 million photos per day, right? Which also means, after making some calculations, 23 photos per second. And that is not a small number, right? If I have to consider the size of one photo, that could be maybe, since there is also some compression algorithms taking place. So to so So to do the capacity planning, along with the average number of photos that we are expecting, we also need to consider the size of each photo. So let's consider we have a cap maybe or some average limit of photos to be at 200 KB. There's some compression algorithms doing its part, right? So let's say each photo has a size of 2 KB. So per day, we would be needing 2 million into 200 KB. That's somewhere around 400 gigabytes of photos to be storing. And this is something that we are considering for only photos. If we have to do it for videos, the capacity planning with videos would also vary. So this is just a rough calculations to give an idea of how do we proceed with that, right? So we need around 400 GB of storage per day, and that is only for the photos. We are yet to come to the database and user data and things that we need to store in the database. So 400 GB of data per day, uh, and that basically is equal to 142 terabyte per year. And if we are making a calculation for, let's say, the next 20 years, this becomes 2840 terabytes per year, right? Uh, we also need to keep it in mind that this is just a rough calculation. This is just a rough estimation that we do while designing a system. The average number of users could actually vary coming with the coming years or coming with the passing of time. So with the estimation, we found that we need around 2840 terabytes for 20 years. I'm sorry, I wrote this is year. This should be 20 years, right? So yeah, this is the capacity estimation that we had to do before diving into the system design. So our system or our service will have multiple users, or let's say multiple clients trying to access our services, right? So some services trying to upload photos, or some services trying to view photos or view the feed, or basically download photos. So if I have to draw them here, they would look something like, so let's call these two boxes as client A and client B, and we have some service for us, right? And our service talks to some database over here. Sorry about my drawing, but yeah, so it looks something like this. Client A would be trying to communicate with the service to post some photos, and client B would be trying to communicate with the service to get or maybe download photos, right? So it would be something like this. So some users are trying to upload the photos, some users are trying to view photos, and our service is interacting with the clients, processing the requests and saving photos to the database or retrieving photos from the database and serving it to the clients who are requesting for it, right? So this is some basic overview or basic component diagram of the service that we are trying to design over here. Let's first talk about on the DB model or the entity modeling, uh, or basically the low-level design of the system. And to talk about that, we first need to decide on what are the different entities or different objects that we need to think about to design this system. So the very first thing that we need that we have in our mind is basically a user, right? We would also have something like a photo, right? Or a video. Let's consider this is maybe content. And since in this video we are only considering photos as part of our design, we can also keep it as photo, right? And we also need to take care of something like follows. And as we go about designing the low level thing of the system, we will also think about how do we model the for user following thing, right? So we are not very sure about the following thing right now. So we know that there is a lot of relations that come into picture while designing this kind of a system, since a lot of users will be following others, the other user will be following somebody else, and there are a lot of joins, right? While generating feed, what I basically need to do is I need to fetch all the users that somebody follows and get all the photos that those users have uploaded and sort them with respect to time and feed it to the user who was trying to get the feed, right? So we know that there are a lot of relations between them. There is a relation between users to users. There's a relation between users to photos and photos to users. And then if we also consider locations, we have relations between photos and locations, users and locations and stuff like that. So at the very first place, RDBMS comes to us as the most obvious choice for this kind of a system. But there are also limitations that come along with an RDBMS system, and with the scale that we are talking about here, there would definitely be limitations that will come along with it. And the beauty of NoSQL shows up here because of the capability of scaling it horizontally, right? So we probably can think about how we can use a NoSQL database just to use the benefit that it comes along with about horizontally scaling it, right? So for the user entity, the details that we will need are maybe uh, name, email, phone, and stuff like that. Also a username, definitely, right? Okay, some ID, right? The content would also have an ID. It would have some caption. It would have a mapping to user posted by, right? And it would have some URL. So we are not actually storing the photo in our database. We will be using some blob storage like Amazon S3, and we would store the URL that is pointing to that particular content or that particular photo in our photos table or the content table, right? Uh, so since we are trying to use NoSQL kind of a database, we can actually use a key value storage, and yeah, so we can have a key value storage, and with ID as the key over these two tables, we can have the values of a JSON object like name, email, phone number, or for the content, we can have caption, user posted by, and URL. We also need to maintain a mapping between user and content, and we also need to maintain a mapping of user to user. That is the following kind of a thing, right? So we would need a table called user content mapping, right? Which would have user ID to a list of content IDs, right? Content IDs. And we would have a follow table. This would basically have user ID to a list of user IDs, right? So what this table means is user content will have user ID as the key and a list of content IDs. So if my user ID is user1 and I have posted 10 contents of IDs 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 respectively, I would have this thing as one corresponding to a list of all the IDs of content that I have posted, right? And if I follow some users who have IDs 7, 8, 9, 10, this would have an array that looks something like this, right? So we could see that we need four tables as of now, and those are user content, and follow, right? So these four tables would give us the basic operations that we need for uploading photos, getting photos, generating a newsfeed, and to follow users. So at this point, we also need to make some estimation on the storage that we would need from the database point of view. So like the estimation that we capacity planning that we made for photo storage, we also need to make some estimation on the data storage, right? So I would suggest viewers to try the thing on their own. So I would also uh, mention a few things that are needed to be kept in mind while trying to do that. So those would be data sizes of the fields, total number of users, and average number of follows or followers. Average follows. So this would again be a rough number or an average number. We don't really know. Somebody follows a lot of people, somebody doesn't follow at all. So this is something that we would have to make a rough assumption on. So keeping these things in mind, we actually can do a capacity planning and that again for 20 years of forecast, right? So I would suggest the viewers to try this thing on their own. Now let's try to make a component design of the service, keeping in mind everything that we had discussed until this point, right? So we would have, let's say, some service over here and some service over here. These two services help me with posting and getting, right? So I'm just segregating the applications because the reads are very heavy and the post application is all right. It's expensive. So to not put load on one particular application, I'm trying to segregate the responsibilities, and this service will basically help with uploading photos, and this service will help with uh, ge- downloading photos or getting the feed or something like that, right? Okay. And we would have multiple replicas of these services, obviously, and everything would be behind some load balancer, right? Let's say RD, and we have clients over here trying to connect, right? And we have another client one, client two, and there can be so on. We haven't drawn it, but we need to keep in mind that we have multiple instances of the services running for us, right? So we also have a blob storage, let's say S3, and we have some database here for the database part of it, right? So posting service will talk to S3, will fetch the URL of the saved image, then it will save this thing on the database. And our getting uh, service will actually talk to the database, get the URL, right? And with that, it'll try to get the image from S3 and it will send it back to the user. Okay, so this looks like a simple overview of the component design that we try to that for the service that we are trying to build. Now, since we are considering a huge scale, we also need to take care of uh, sharding the data or maintaining replication of the database and things like that, right? We already discussed about the thing, but now let's just draw this thing out so that it's very obvious about what we are trying to do. Yeah. So we have multiple instances of the post application running, right? And we would also have multiple instances of the get application running for us. Right? And the load balancer is in front of them to decide which instance gets the request or processes the request. We also need to take care of multiple instances of our blob storage and multiple instances of our database, right? Those could be replications to serve reliability. When one blob storage or one database goes down, we at least have somebody else to take charge of the further request, so that we don't lose database or our application doesn't actually go down. Okay, now to scale this to multiple users, we probably need to shard the data. Okay, so now, as we talk about sharding, we need to think on with respect to what are we going to shard the data, right? We need to have something unique with every user or some set of users which will guide them to one particular shard so that when the user comes back, we know which shard to go to. When a user one posts a photo, let's say I stored the photo on shard one, and when I need to get the photo, my application should know which shard to go to get the data from it, right? So the very basic thing is we probably can shard it based on user ID, right? And here we are talking about sharding. Let's say we are maintaining n shards. To determine the shard ID, we can do something like user ID percentage n. This will give me the remainder, which can be, okay, let's call this X, and X is the shard number for this particular user, right? This actually gives me a decent sharding strategy, which can definitely be implemented. So with this strategy, let's consider we have some number of users, uh, which are denoted by user ID 1, 2, 3, 4, 5, 6, user 7, user 8, user 9. And let's say our n equals 3, we have 3 shards that we are maintaining. So this will always go to shard 1, 2, 3. This will go back to 1, 2, 3, and 1, 2, 3. We can see that we have some uniform distribution across shards, right? So this is very well and good. But there is one limitation over here. What that is, let's consider we have some user hotspots, or some users are very active and some are not. What if user 1 is very active, user 4 is very active, and user 7 is very active? In that case, we can see that shard 1 is the one which is receiving huge number of requests, whereas shard 2 and shard 3 are not, since user 2, user 3, user 5, user 6, user 8, and user 9 are not very active. So if we shard it based on user IDs, there could be, irregularities in the amount of traffic that is being divided across the shards, right? So what is some other approach that we can go on with? We probably can shard it based on photo ID, regardless of who uploads the photo or who uploads how many number of photos. We shard it based on the photo ID, right? So with this, we need to make sure that there's some logic to generate some random photo ID or an auto incremental ID. For the auto incremental ID, we have to maintain a database which gives me auto incremental values. This is not very straightforward, as our data is sharded. Having one auto incremental ID across all is not very straightforward. So we need to maintain it in another DB layer, or maybe in the application layer, which will generate the auto incremental ID for me, right? And the other approach would be probably using some random ID. And if I have a six digit number, or let's say six length string, and I do a base 64 encoding of it, I will then have around 281 or 68 billion possibilities, right? It is. And if I have some 8 length string as the unique ID that I generate, and I do a base 64 of it, I can have around 280 trillion unique IDs, right? So we definitely can generate unique photo IDs, and based on a photo ID, we can do a sharding based on the same hashing algorithm, or whatever algorithm we decide on. And based on that, we can actually shard the traffic, or shard the photos, or shard the users, shard the data basically. So this could be a working solution for the sharding part of it. Now let's come to the last part, for that is the news feed, and this happens to be the most interesting and the most complex part of it, right? So to generate the news feed for a user, let's say user 1, what I need to do is I need to fetch all the users that this user follows, right? Which will return a list of user, right? From this list, yeah. So from this list of users, what I need to do is, for each user, I need to get the photos, right? And then I need to map it into a list of photos. And lastly, sort it based on date, right? So these operations are not very, so these operations are a little expensive. We would have some ranking algorithms running behind for us in our application layer, which would rank the photos and sort the photos based on date and popularity and stuff. But then again, these are not very efficient. These are a little expensive for us. So since our system is very read heavy, making these computations over and over again would actually put a lot of load on our system, right? So, what is some kind of a solution to improve this thing? So, this idea that I'm trying to uh, put here is something that I read on the book called Designing Data Intensive Applications. Intensive Applications by Martin Kleppman. Kleppman. And this was mentioned in the book as part of Twitter's system design. And what basically happened was we maintain some kind of a cache for the user's feed, right? So what happens is in our component, we would maintain some form of a cache, and when the user tries to get the feed or get photos, our application will go to the cache, get the feed, and give it back to the user, right? How do we maintain the cache is basically, let's say my user 1 follows user 2 and user 3. What my cache would basically do is, let's say user 1 posted photo 1, photo 2, and this user posted photo 3 and photo 4. As soon as these photos are being uploaded, what I would do is I would I would see who follows these guys. Okay, so as soon as these photos are uploaded, what I would do is I will see who follows these users, and once I find user 1 following user 2 and user 3, what I would do is I would push photo 1, photo 2, photo 3, and photo 4 into the cache for user 1, right? When user 1 comes back and tries to do a get feed, what I would do is I will go to the cache and I'll return the cache values to the user. So there is some pre-computation involved here, right? Which is improving our things by a huge margin. This is not this straightforward, but some kind of a logic can be implemented. Some kind of a logic which is similar to this can be implemented. So we can pre-compute the feed for a user. Whenever somebody uploads a photo, he or she follows, right? So this thing can actually improve the feed generation logic. This cache can be uploaded with a pull when the user uploaded with a pull when the user does a uh, force get on it, get feed. Once I feed the cache to it, the user tries to get the feed once again, which basically means probably the cache is not updated. In that case, we go to the database, fetch new photos, and update the cache and feed it to the user. And push, right? Push is basically whenever a user uploads a photo, we push it to the cache for those users who follow the particular user, right? That is uh, the one that our system or our application level does it for us, update feed. So based on push and pull, we can manipulate the cache and feed the user with the feed that he or she wants to see, right? This thing is actually implemented on Twitter. I am very sure something like this also exists across all the social media services. But this is not, again, very straightforward. There would be users like, let's say, Jennifer Aniston, Conor McGregor, we who would have millions of followers, right? And updating caches of all those million users is again another very expensive operation, right? So this push and pull operations are not done at every upload or every get a feed that also is based on some logic based on the audience that we are trying to serve here, right? So this much amount of discussion is probably enough to cover a system design interview, and this gives us a basic idea of how a social media service like Instagram performs. So yeah, that's pretty much about it. This was not something that I have prepared across over time, and this is something that we have discussed uh, while on the video. I definitely have read about it over the places, but this discussion right now is something that I am doing while recording it, and this is something that I would probably do while in an interview myself. So yeah, that's pretty much about it. Thanks a lot.